Welcome to another video of the PLC programming series by Automation. Today, we're going to see how we can start and stop an electric motor by writing a ladder logic PLC program using Siemens TIA portal. It may sound very easy, but let's see which important practical points are hidden in this simple PLC program. If you haven't watched the part 1 of this series about creating a new project and configuring its hardware in Siemens TIA portal, then please use the links in the description, take time and watch that video before this. If you are new to this channel, please go ahead and subscribe and click the bell to receive notifications of new videos. As always, first we have to calculate the number of inputs and outputs of the process to and from the PLC cards. We have two push buttons, one for starting and the other for stopping the electric motor. Each of these push buttons has an indicator lamp inside to signal the condition of the motor to the operator. Therefore, we have two inputs to our digital input card from the push buttons and another input from the contactor's auxiliary contact. We use the input from the auxiliary contact of the contactor in our PLC program as the feedback for the electric motor status. Is it on or off? By the way, we have three outputs as well. One for turning on and off the electric motor, and the other two are for turning on and off the indicator lamps of the push buttons. I've opened the TIA portal beforehand, created the project, and configured the required hardware. I've also added the symbols to the tag table according to what I explained. As we have learned in part 2, from the Basic Instructions tab, under the Bit Logic Operations folder, I drag and drop an SR flip-flop and assign the motor contactor coil output, or Q0.0, to that. We have explained about flip-flops in part 2 and 3. I then connect an open contact to the set input of the flip-flop for the start push button. And of course, a closed contact to the reset input for the stop push button. You don't know why I use the closed contact for the stop push button? Then watch the NO and NC contacts video. I move on to the network 2 to add the logic for indicator lamps. When the electric motor is not operating, the stop lamp should be on and the start lamp should be off. So here I need the NO contact of the contactor, and I assign its input address to this open contact. Then I use an assignment or output contact for activating and deactivating the start lamp output. Let's do the same thing for the stop lamp. So this time I use a closed contact, but with the same address. There is an important point here. When the actual physical contact is open, the state of its equivalent PLC logic contacts is like this. And when it gets closed, its input to the PLC card, which is I0.0 for example, gets active, and their state will be updated like this. So do not confuse the open and closed contacts of the PLC logic with the actual NO and NC contacts. Now let's do a quick simulation and discuss another important practical point after that. I save this project and compile it. As you see, there are no errors or warnings. Since in part 3 we covered the procedure to make the software ready for simulation in TIA portal, I skipped this step. As I explained, the stop push button has a built-in normally closed contact, and in the normal condition, when it's not pushed, it sends a 24-volt DC signal to the PLC's input card. So I simulate its input to 1. The start lamp is off and the stop lamp is on, and that's okay. Let's start the electric motor by pushing the start push button. Now, the motor starts working. I force the input from the NO auxiliary contact, which is I0.2, to true as well. Therefore, the start lamp turns on. If I push the stop push button, the motor stops working, and I also should change the state of the NO auxiliary contact to false. It was quite simple, right? For activating and deactivating the lamps, we could also use the contactor's coil output, Q0.0, but as you may have guessed, it's not according to the actual situation in the plant, where we have to check the functionality of the contactor in our PLC program to see if the electricity is really flowing toward the electric motor via the contactor or not. In addition to the contactor functionality check, sometimes, where it's possible, we should use a proximity sensor on the shaft of the motor to make sure if the motor is really running and is not stuck by any means. In this way, as long as the proximity sensor's input to the PLC card is getting on and off with a certain frequency, we are sure that the motor is working. As the last point, one of the important automation documents or drawings that is used frequently during commissioning and troubleshooting of the process is the control panel wiring diagram, in which we can find the power and control sections of the process. But this schematic that you see here actually does not really count as a wiring diagram, but it's a simple schematic drawing for better understanding the concepts. If you want to learn to read and understand an actual wiring diagram of a real control panel, you can watch this video from the link in the description. In the next videos, you'll learn how to design and draw a simple but standard wiring diagram using an ECAD software such as ePlan. I again suggest you subscribe for more of these practical and informative videos, and if you like this video, please press the like button and share it with your friends and colleagues. You can watch the previous parts of this video series as next. Thanks for watching.